Today, my guest is Mahesh Tyagarajan, former VP of Platform Engineering at McAfee. Mahesh and I have worked together at eBay. His impressive career spans large scale companies including Walmart and Kroger. He has led major automation and transformation initiatives in all these companies. In our conversation, we dive into three key areas. First, Mahesh shares insights on building successful platforms at scale. Second, we discuss developer productivity and how Mahesh reduced onboarding time from months to just 1 week at McAfee through smart automation. And third, we examine how AI and autonomous systems are transforming cloud management. If you enjoy this podcast, do not forget to subscribe and follow it in your favorite podcasting app or on YouTube so you won't miss future episodes. With that, I bring you Mahesh Tyagarajan. Welcome to another episode of Future of Cloud Optimization. With me, I have Mahesh T, former VP at McAfee. Mahesh and I have worked together at eBay. Then he has went to Walmart and a few other large-scale companies to make things automated. Mahesh, welcome to a new episode.
Thank you for having me, Suresh. Glad to be here.
You have led multiple successful initiatives in these large companies, especially when you take companies like Cafe and Walmart and Kroger at scale. These are all extremely hard problem statements, right? It's one thing to solve something for 5 people. It is a very different problem statement when you try to solve it for 1,000 people. And what are your thoughts there? How do you build something at scale?
Building something at scale, I think ultimately it comes down to the team. It's all about the team. So, in a lot of cases, at least in these three examples, the teams have to come along with you. You're taking them along on a journey and they have to believe in you. So, I think invest time in the team, make sure that the vision and the architecture and the principles are very, very clear. Then what will happen is the team will start having that buy-in. What I found invariably is it takes a little bit of proving out that they will then know that like you're leading them the right way. And that's usually when the first live workload is up in production, right? So and starts taking traffic. And then all those principles that you put in place get reinforced. So team, reinforcing the principles, stay with the patterns that you put down. There are different types of patterns. Every company would have different ones, but like whatever is like very important to the implementations you're doing, I would say stick with it, and it'll pay off as the team start realizing and start working towards actually achieving the larger goal of the transformation. Because you have to show success not only to your business partners and product management and your exec team, but also to your own team. So I think that is very, very key.
Start small, measure, scale up.
Right. Small wins, right? For example, Walmart, right? When I walked in, we were obviously up against Amazon was competing very heavily with Walmart at that point. It was 2012. Walmart had tried to rebuild Walmart.com maybe 5 times over before I got there. I was the 6th person to get there. And so there was a lot of headwinds from a business believing in you and everything else. So I had to show some small wins. So first thing we did was take the homepage, for example, right? It used to take us a month to ship the homepage. Walmart.com used to ship once a month. So we said, like, okay, we're going to break it apart. We're going to ship it. And then we were able to ship it 15 times a day at the end of a quarter to say like, hey, we put those principles in place, CI/CD, automation, just the architectural principles, componentization, whatever else that you might think of as important steps to actually make that happen. So that gives you a little bit of credibility to say like, okay, now you can go look at the rest of the other stuff, right? So I'm just giving you that one example, but McAfee was the same thing. Logins were having problems. So we went into a solution we bought in this particular case, and that's what we were using for the login and the authentication aspect of McAfee. So had to show those initial wins to say like, okay, we believe in this person. We believe that this person can take you to the other end.
Now, switching to platformization for, especially for large companies, right? When you think about modernization, when you think about transformation, you generally have one platform team or one platform that paves the path, right? Now, at eBay, at Kroger, and I'm sure at Walmart too, you must have gone through that journey, right? And metrics, I understand from you, as a key component. CI/CD, you just mentioned that. I'm thinking DevOps platforms also is one. So how does one think of platform? How does one think of the success criteria for a platform? And how do you manage or make a successful adoption across the company?
Absolutely. I think my belief in what a platform should do, the platform should obfuscate the underlying technology choices that you make. And I will explain that in a little bit. When you take a cloud native architecture or you take anything in AI, right, you have some components. For example, in cloud native, you would have an observability, you would have a data access, you would have bulk movement of data, you would messaging, you'd have all these things that are technology components that make your application come to life. A platform, in my view, actually is something that removes the shackles from applications to having to worry about these things. So build a layer of indirection that allows you to swap out the technology components and piece parts underneath the hood without the application ever having to change. What that does is it allows the application developers to concentrate on adding real business value and velocity rather than having to do the non-functional but yet necessary code over and over again. Whether it's ORM, object relationship mapping, whether it is messaging, whatever be the case, right? So I'm just taking those as examples. The same is true for AI, right? So the data pipeline, the tooling, the data quality, those will all be the things that we'll be thinking about and saying the same things about, like maybe 2 years down the road or 3 years down the road as it starts to mature. I know we're in the initial stages of adoption and various folks have been adopting that. So I think there are a lot of parallels there, but I think a platform that takes care of these non-functional yet necessary automation and more than automation, the observability, because things are going to go wrong. How quickly do you get to the bottom of what is going wrong and being able to take corrective action? Are you instrumented well enough to be able to react quickly? And that's, I think, the key. So all of these are aspects of the platform, which I think will go a long way. And this is the highly opinionated view, but like it has stood me in good stead for the large transformations so far.
Especially in the AI use case, I always say this, like in this case, we got the hammer first, and now everyone is looking for a nail. What do you think of that? Right? Where can we apply it meaningfully? Right? That meaningfully is emphasized here, because I have seen many companies trying to figure out how and where can I use it.
Yeah, so I look at this as a continuum, and I'll tell you why and where we are in that continuum. So initially, we started with prompt engineering, right? So we started feeding ChatGPT, Copilot, whatever you might think of. Like you're feeding it with prompts, then you're doing the text extraction, text setup, all of that, right? So in essence, it was around prompt engineering. Then now we've graduated to doing tasks. It's not only asking a question, getting an answer, but actually letting the machine do certain things for you. And that's where it became agentic and that's your transformation into agentic. I think the cost of training models is coming down. So you will find a deployment of like very specialized topic centric models going forward. And I see a huge advantage for open source models in this world where you can pick and choose. If you go to, say, a Hugging Face or something like that, you'll find 100,000 models plus, right? So it's like there's a lot of them out there. You need to pick and choose what is appropriate. And you can use that as a starting point to then drive what could be a topic specific model for the problem you're trying to solve. So I think you see this continuum, right? From prompt engineering to agentic to actually deploying your own models and running and operating models within your VPC. In all of this, the basic problems remain the same: data quality, being able to feed that data to the models, actually having a response time when you're querying it at runtime, come back within time. So I see this platform notion and how you can apply it is like, okay, first we start automating this low-hanging fruit, right, through these agentic tasks. It's really not a replacement for humans. It's like taking the boredom and the repetitive tasks that you want to do. Okay, I'm out of space. I need to increase space on my database. Right? Things like that. Those are that's a good example of something that you could potentially give up to an agent and say, like, okay, I know what's happening. I know what's going to happen. So let's go do this. Right? That's a good example of an agentic task. And I think in all of this, the quality of data matters, right? Those metrics that you so rely on should be reliable. Otherwise, you would be doing the wrong action because you saw a data point that was not correct, or the machine saw the data point that was not correct. So I think it's going to be a human machine interaction with a lot of the mundane tasks initially be taken care of. Or like if it's highly combinatorial, the machine can guide you towards which is the most appropriate action to take. If I've seen a say like yes, system failure, right? So I've seen this before, I've seen these logs from before. Oh, by the way, this is what you ended up doing at that point. It could still be the human making the ultimate call, but it could help cut down that analysis time and hence bring down your MTTR, mean time to recovery, right? So that's MTTD and MTTR, detection and recovery. So I think those are examples, I would say, of like really, at least from a compute and observability, that's and the platform perspective, that's what I gravitate towards because that's near and dear to me.
That is where our mission and vision is too. So we have like a good set of Fortune 100 companies where we run most of their mundane tasks autonomously, like agentic AI for that matter, right? And these are not the decisions that humans enjoy taking. These are the decisions that humans always say it's quite boring to do it, right? It's such a simple, straightforward task. You just have to look at 5 metrics, look at the trend, and then take the decision. So that decisioning now people are moving towards agentic AI systems like Sedai. So you know what? You guys take care of it while my people are going to focus on higher order tasks. So that's our mission too. Coming back to the development,
Excellent.
yeah. So that's where I think it aligned, although it was not planned, it aligned. But now coming back to the developer productivity around this, right? So I see that you've taken the developer productivity landscape, developer onboarding time from like days to minutes and McAfee, right? So what was the journey there?
Yeah.
How did you manage to get there?
Yeah, I think it was more like a few months down to a week or so, right? So the example I give is when I joined McAfee in 2021, it would take a developer about a couple months before they're pushing something like an API into production and for it to do meaningful stuff. There are a lot of architectural things that were different and it was very monolithic. So leaving those aside, just to write an API to be able to take traffic. So what we did was the following. We automated, like I was mentioning earlier in our discussion, we automated the mundane pieces like the logging monitoring, like database access, file access, ORM, uh, serialization, deserialization on the wire, right?
Nice.
So all these things were just taken out of their hands. So they were given a little sandbox that they could play in where they were writing valuable business logic, and that's all they had to focus on. And we also attacked the monolithic nature of what you would have to do. So we had layering in place. So there was a data layer at the bottom. There was a functional layer that hid the nitty-gritties of data that was more at a domain level functionality. So that's the functional model. And then there was an orchestration layer on top which is where all the business logic would live and the higher elements of that use cases would live, right? So by doing all of this, we would be able to you could walk in, you could look at we were building it in two languages, Go and Node, and we were polyglot. Anybody walking in had to know Go and Node, and so that they could go between the entire stack. You would start by writing your data and your functional services in Go, and you'd switch around and write your orchestration in Node. And if you walked in on Monday, by Friday, you would be able to push something live into production. So it was literally an example where the productivities, and this is not one thing, this is several things. It's like that adherence to architectural principles, sort of, okay, taking away some of the coding, not some, a lot of the coding of the non-functional but yet necessary pieces, right? And then also by saying okay, by doing this, it's going to spit out unit testing. So but the test harness was built into that. So once you were writing code, you couldn't check in. We had gated check-ins. You couldn't check in until you built the testing for it. So it would go hand in glove. And all of that would end up with higher quality, less breakage, but faster, much faster end-to-end delivery of what the person should be building.
Beautiful. Basically, componentization, platform components, logging, data access layer. Maybe some of these API calls are also available for them. So they just write the business logic and the code. And the test also, the basic test is also available. And then there's a CI/CD that takes it from dev to production. Nice.
That's right.
You got it for
anyway, and that was the most important thing. I thank you for bringing that up. I would say you're not done. You're not done testing till it is actually deployed in production. It should be container. It should be in our Kubernetes container in production, being able to. It's the equivalent of hello world, but yet taking traffic in a container on the cluster in prod and things like that, right? So and that was the yardstick by which we started measuring our engineers, and they learned a lot. In fact, a lot of the engineers would come back and say, "Thank you, Mahesh," because we learned so much in the process, because we learned this whole thing. It's not like this black box where I throw it over and then something happens and someone else pushes it to production. So it's one of those things that really helped all of us learn the entirety of the process and get better at it.
Very hard problem statement, and not an easy problem to solve at all. I can completely relate to it. Yeah. And in this process, how did you choose between a build and buy methodology? In this process, I'm sure there are 50% you can build, and you are best, or your teams are best bet. Best bet would be for you to build, and in the other case, it would be probably a buy.
Good question. And there's a lot of things where it's not a cut and dry build versus buy, and I'll talk a little bit about that as well. So usually platform components are a build. I mean, a buy, which means you end up messaging. Nobody is writing message.
Exactly.
Nobody is writing a database. I mean, nobody is writing an API gateway, right? So what we do is we build enough to be able to swap between one messaging infrastructure and another. So for example, I inherited OSK, open source Kafka, but we built a layer so that we could then go to a managed service provided to us by Confluent, right? That's a good example of abstracting away the underlying, so I could change the underlying piece without the application knowing what is going on. And we did that. We started with OSK and then we swapped it out for Confluent as an example. Using managed services where it's really complex, and it's the same example, right? Kafka is inherently hard to manage. It's not an easy set of things to just manage on your own, right? Let the experts do it. Right? So invest in managed components and managed componentry as much as possible. And when I say manage, I would say things like authentication. So we were using Okta for our authentication. they're the industry leaders. I mean, let them do it. I mean, there's no sense in us building authentication and logging and preventing against DDoS attacks and whatever else, right? That's what they're really, really good at. So that's one aspect of the buy. The second aspect is like your own at the other end of this of the pendulum and the spectrum is your IP, your intellectual property, right? So whatever you bring to the table, threat protection is what we were doing at McAfee. That's our bread and butter. So that's obviously a build, right? So the business logic behind that was obviously a build, right? Whatever we needed to do, detecting it, protecting you, telling you what actions to take, the whole 9 years. And those were all things that we would build. And there's this little gray area in between where we build and we bought, right? So observability falls smack dab in that. So we're a big OpenTel shop, but at the same time, we would use FluentBit and FluentD to be able to hook. So while one part of it would get fed into, Loki, Tempo, and Prometheus, the other part, we would just fork that traffic and push it to, say, CloudWatch or push it to whatever else, right? So we could do it, and we could control how much went into the managed service so that we could control costs. At the same time, we would use that as like the starting point for us to then look at the more detailed information in Loki and doing your more detailed analysis. So we were able to have like this nice hybrid of the two worlds where you would use the managed service, and CloudWatch is fantastic, right? But for certain things, it made more sense for us to fall back on Loki and Tempo for that matter for tracing. So we would do that. So having that, like, the application is again blissfully unaware you're doing this. Under the hood, we are forking that traffic and then sending some of it two ways: one to our own OpenTel infrastructure, another to monitoring in like a managed monitoring service.
And the decision is done at the platform component that is to the path.
That's correct. And that spigot can be controlled, right? We could do percentages, we could do levels, we could do certain types of mess. So there was a highly configurable nature of what went where, but everything would end up in Prometheus, Loki, and Tempo. What you forked was what you're deciding.
That's good. That probably is one of the best ways to manage cloud in a controlled manner. At least you know where and how we can control some of these.
Depends on the capability of the team, right? So I would say a little bit of like, even when you buy stuff, having some DNA to be able to work with that, so you understand what you're missing if you're missing something, right?
Yes.
Or everything might be great, right? So that is, I think, very critical for you to be able to discern what is needed, what could be the potential advantages of doing some of those things. And why is this important, right? The developer, when they're developing these things, they know that they have their setup. All they're exposed to is YAML, and like they're configuring everything in YAML as they're actually then handing it off to the CI/CD pipeline. That'll go and configure all of this downstream, which is in an automated fashion. So that automation was something we invested very heavily in the DevOps aspect, right? So as we built that piece, right? It's obviously I'm saying this in one sentence, but it's the most significant win that we got in the level of automation we got over there.
100%. Now, coming back to cost, since we are talking about cost, right? So generally, cloud cost is an area, not just monitoring aspects, but cloud cost as a whole is an area that the industry is now heavily looking at. Right? How can I optimize?
That's right.
What shall I do? Should I buy a FinOps tool? Should I do it in-house? What are my options? Right? Is it going to be a task I will have to deploy a team forever? It's quite boring. Should I do that? Can I get some help from somewhere? Should I use a service or should I use a product? A lot of things around it. So what is your take on that?
I might be saying something very contrary to what others might have said. So bear with me. But what we've seen is if you host something versus actually have it be managed and hosted by a provider, whether it's your hyperscalers or whether it's like an ISV who's providing that solution, right? The cost is kind of a wash. It's kind of like six of one, half dozen of the other. It's not that different. It's like you want to figure out what is important to you, right? Do you expect that there's going to be a lot of change in certain aspects, and hence you want to keep that and hold on to it? For example, the OpenTel observability, we split it. We knew we could use CloudWatch, but yet we wanted to have the ability to do our own reporting and own actioning and things like that, right? So, for example, we have a lot of endpoints out there as McAfee, right? 35 million plus endpoints over there. They're sending telemetry all the time. You want to take some action, and it's a very, very big pipe of data that's coming at you. So, and you want to be able to do something, and eventually it's germane to your system. It's like your systems are going to take action on those endpoints. So that made sense for us to keep in-house. So I think you want to give things that are hard, and you don't want to build expertise to the to manage services. You want to keep your own IP and things that are very fast moving, which could change very often. There's a cost of changing that on when you deploy managed service, right? So it is also whatever your processes are, your operating processes are, and things like that that come into play. And you have to make a decision. There's no black and white, but more or less the cost would end up more or less in the ballpark. It might be a bit, yeah.
It probably evens out. Now, double clicking on the hyperscaler aspect. So let's assume one company decided to move to public cloud and not do on-prem. Cost is going to be the same. And from an optimization standpoint of that cloud resource now, because it's going to be a CapEx for most of them, OpEx for most of them, and they would want to optimize it as much as they can. And a few things come into play. What I've seen companies struggle is performance is a huge component in that decisioning. Cost itself is one. And the third is really availability. I'm making some decisions that's going to hurt my customers or my application or my brand. It's a much larger question, right? How do you make sure that there is a system that can handle it and it handles it well?
Yeah, I would add one more to that list. I would say utilization.
Yes.
So, which is basically to say, like, some might be underutilized, some might be severely oversubscribed, right? So, I'm going to say something, and like people might jump all over me, but this is where human beings are not good. This is where machines are very, very good at giving you unemotional data about what actions you need to take, right? So, and then you can go start looking. So, first, I would say is to instrument to be able to gather this information. There's a lot of stuff that is available in terms of software that you can put in place that can monitor your utilization, monitor your resources, whatever be the case, right? There's that. Second is like, see if there are patterns that can do that. And those are the ones that you can start looking at. You can do small things. I'm going to give you an example. We have a 12th minute spike in our traffic. We've seen this for years and years at one of my previous companies. And what we did was we reduced the spike, but that spike was still there every 12th minute. We get a spike. And so we can't auto provision. When the spike hits, you cannot auto provision. We'll be out of resources if we start auto provisioning and leaving everything to auto provision. So we would ramp up the provisioning, say 5 minutes prior, and then take it down 10 minutes later, something like that. So instead of having it entirety of the time, we reduced it to 1/4 of the time. So having it at capacity. So those are the kinds of things that you could potentially think of as being able to do from an automated fashion. There are a lot of tooling, a lot of things that are. The hyperscalers give you fantastic reports about your costs. I mean, if you're an operations person, you have access to that data to the minute detail. You will know exactly where your spend is. I think going after the big ones, right? And looking at it saying, not to necessarily go cut it. Is it justified? Is this really needed for that particular use case? Or is there a better way? Sometimes it might lead to you changing the way your application works. Ultimately, the customer might not know any difference, but you would have handled it differently from how the technology stack is handling it. So there are lots of ways to skin this cat. And I think each company can determine what is appropriate in their particular scenario. But I think looking at the data, automating around this things that are very predictable, and then going after the big hot spots, right? And those could be like costs, could be things. And there's a bunch of out there. And I'm not very familiar with the landscape, but there's a lot of tools just looking at the cost optimization aspect of it, which is like looking at your resource or utilization, cost optimization. Can you put more workloads within the same cluster? Those are the kinds of things like you could virtualize on the cluster. You could have more services being served up by the same cluster, right? So obviously there's like a management overhead over there, but like, is that a trade-off you want to do? Are they complementary in terms of the resource needs? Are they complementary in terms of where the spikes happen, if there are spikes, right? So things like that. So there's a lot you can do to actually go that route as well.
Almost like an oversubscription and the others. So I had one thought around here, the 12-minute spike example that you mentioned, right? In my previous companies, we had spikes, not really at that time. It's probably some time of the day, let's say. There is New York waking up at like 9 a.m. PST, and we know
9 a.m.
exactly. So that's when we get traffic. And what we have done at Sedai, the company that I am right now, is we call it predictive modeling. What we essentially do is your traffic goes up, but there are lead indicators that tells me that the traffic is going to go up, right?
Right.
And we call them lead indicators and start getting this initial hints, early hints that it's going to go up. And we call it the lag metrics that we get reward from everything is healthy. So when it starts to go up, the valley of that slope, right? The y equal to mx plus c, the slope goes up. There are lead indicators to tell you that the slope is going to happen now. We start tailing out right there. So you kind of get an even or smooth readiness for that planned spike. So for most seasonal patterns, these kind of methodologies work for our customers. That's what we do.
This is fantastic. I mean, this is something that a lot of companies could use, because like once you can start deploying something like this, it gives you a little bit of peace of mind. You might still have eyes on glass at that point, but like you have help in addition to those eyes on glass. That it's the reinforcement learning that everybody talks about. And
exactly,
yeah. So and I think this is a great example of that, right? A lot of times we've been doing these things without even calling it such, right?
Right. Right. We didn't just name it that. You're right. You're absolutely right. So, Mahesh, that's what I was thinking. So, one challenge that I see generally with anything AI or autonomy is how do you build that trust? Because at one point, you're almost seeing a machine trying to do something. And how do you build that trust that the machine is not going to make a wrong decision? And at least it's going to make a better decision than any of us.
I think percentage traffics come to mind, where you could have a blue-green deployment, and then while you're still in one deployment mode or the other, small percentage, see how it does, see whether it's doing all the right things in terms of that percentages, right? So the load balancer in front is going to like just give it to A or to B based on whatever percentage you set up. So if a traffic pattern starts to spike, it's going to spike equally on the 25 that is in test versus the 75% that is actually taking the, right? So I think those are the things. And then using the training from that to actually take either corrective action or being able to take, have some kind of a standby to say like, hey, I can flip the switch on that 25 that could be going wrong. I can flip that traffic over to another 25 I have been waiting. Something to that effect till such time you can get your confidence up that the machine is doing the right thing, right? So obviously you're verifying that what you just letting the machine do is actually working. That comes to mind immediately. The other is to actually do data, analyze the data, right? So look at it from past and say like, okay, like simulate this whole thing, right? And what would the machine do, and see what the machine does in a simulated run. And so I think those are the things that immediately come to mind. There might be a more clever answer to this, but like those are the things that actually make
That's why. Yeah, no, that's exactly what I've seen customers doing it. That's how generally we build trust. We start probably with test environments or probably not so important applications to just build the trust. And one thing I've seen working is once we start enabling an autonomous system on availability, there will be a few incidents that the system would have avoided and they would have saved some calls, right? That probably is the aha moment. Like, oh, no, you know what? If you enable this, then I don't have to be on this call midnight. Or this issue would not have happened if the system was guarding us, right? Those kind of things are like huge triggers for them to say, you know what, now let's turn off. It's not going to cause a problem. It's saving at least a few incidents.
And the other thing I can think of, Suresh, is the following, right? So we always have we have a stage and a prod, but in between we have a performance environment. So performance environment is where we test for scalability. So you know the patterns on that perf environment. You're hitting it from the outside. You're ramping up the pressure. What you can do is sort of set up your performance tests to kind of look at the various scenarios that you might be seeing, and you can do this at will and see whether the machine can actually do that. So perf environments also might be something. It's an additional thing. I'm not saying don't do the other things, but I'm saying in addition to that, if you have
like an LLP or a launch.leak plus.
Exactly. Yeah.
Now coming back to AI, where do you think the future, or what do you think is going to be the future of AI in cloud management, cloud optimization, and platformization? The whole platform team, how is it going to impact positively us?
Yeah, I think it's going to be a huge help, right? That's how I think about it. It's going to help drive up the availability. It's going to drive up the reliability because it's going to catch the things before something happens, because it has seen that pattern before. There are a lot of companies trying to dabble in that, but I think as we mature and the models get better around that, or we can train the models to be better around that, depending on what you're doing, you will be able to fend off problems that could have actually made you take an outage. I was recently listening to the CEO of Siemens, and he was talking about AI being used to study the mechanical failure of train doors. And they would predict when a train door might start to fail, they would take it out of service prior to it happening and fix it.
Wow.
So fantastic, right? So that's the analogy I wanted to bring up. I think we could do something similar in all of our software systems, right? You could predict something could potentially go wrong prior to it happening because of the confluence of events that are starting to come together, and say like, oh, we think A, B, C, right? And that would be something that we can learn over time. So models will get good at it, and guess what? It is actually making the human being in charge look better because they were able to actually catch and prevent an outage rather than having to take that, right?
Yeah.
So I don't think it's it, and also it might not be able to do everything on its own. It might just alert you to do it, right? The human being might still be absolutely essential in making the right call, but you know what that pattern looks like, saying like, hey, I've seen all these things. This is what you've done in the past. It might be slightly different. You might have to do slightly different things this time around, but it is going to give you a heads up. That's one. I think open source models are going to be huge, and the cost coming down, being able to have very custom models for specific tasks, right? So you might have like, I don't know, something for just, I'm just throwing this out there for databases and database monitoring, right? There might be a model that just does that. For example, I'm just throwing that out as an example, as against a workload that is containerized and the characteristics of a container-based system and the health of the containers themselves, right? So there might be things that you could do that are very specialized. You're not asking it about French poetry, for example. You're just expecting it to give you that very, very, very specific answer. And that, I think, will help us scale. And what I'm saying by that is there could be AI in lots of mundane things that we do, and we just naturally do it, right? There was a time when the internet was just like what content that we could share, like back in 95, 94, something like that. And then today, everything is out there, right? So it's an integral part of everything we do. I think AI is going to get there. It's just going to be a matter of time. And I think there are a lot of bright minds at it. I have faith that good things will happen. And I think the problems will still be the same. How can you get it great data? Can you get it reliable data? How do you reinforce with the right data sets? And how do you remove duplicates? How do you actually clean up the data? How do you quality check the data that you're feeding the models? How do you even do the extraction and the pipeline of getting the data into the hands of the model so that the model can do its business, right? So I think there's going to be an ecosystem, just like a cloud platform, which has, 50 jigsaw piece puzzles, right? I don't know. I'm just throwing it out there. Maybe there are 300, whatever that number is. There will be 50 or 100 or 120 jigsaw piece puzzles for an AI implementation, right? For like a soup to nuts. And each one of those will get commoditized. Each one of them will have like lots of different options. Each one will have different models. I mean, like if you look at it, go look at Hugging Face or something like that, you'll have like, hundreds of thousands of models available over there, right? So it's like that world is happening around us. We will be able to pick and choose, and we will be able to get to the point where all of these will be very custom to the job that is being done, right? And very, very bespoke to the job that is being done. And we will make use of it to do that really, really well, and ultimately help us do higher value things that are more important.
100%. This probably is one of the best examples of an AI in action in my podcast. So thank you for that. So that kind of is why we build this company, right? So you can build companies for multiple reasons, right? One, you can quickly build, get some investors and sell it off. That's one option. The other option is when I was at one of the largest finance companies in the world, I saw these engineers always in harm's way, trying to protect the company, doing the things that they thought was right, and ending up in incidents. And at certain cases, I have to even walk them out, which is not fun, right? And when we looked at the problem sequence, we said, you know what, these guys are too smart for these kind of issues. And that's why we said, can we build something that can fix the problem? That's why we rallied all the large companies first into our mission, right? So if you look at most of our friends of Sedai or customers of Sedai, they are the large companies in the world, like Palo Alto Networks, HP, Expedia, Experian, GSK, Cat One, right? All the large companies, Magro. So we're bringing them together and say, in order, let's make sure that engineers and admins are now looking at issues that they find interesting, and we are not really putting them in harm's way. Let's see if the model can do some of these things and give them that peace of mind. Let's not wake them at during midnight while they're sleeping. That's why we've built the company. That's why we exist, right? So that's
fantastic. It's fantastic, and I think there's a huge need for that, right? So that's how I see it, right? So from where obviously the fast changing landscape, I would say like enjoy the ride. It's going to be fantastic. I mean, there's going to be lots more things you'll be adding to that portfolio and the list of capabilities that you bring to bear. So I can't wait to see all that's coming from you guys.
Perfect. Thanks, Mahesh. And I have one last question for you. So let's say there was something called Cloud Olympics one day, right? what would be an item that you would be winning for sure?
Observability, man. Observability. Because I think
No.
if you can observe what's going on, you can solve all the other problems.
Exactly. Perfect. Thank you so very much, Mahesh, for your time. This was super insightful a conversation. We really, really enjoyed the time with you. Thank you so much.
Thank you, Suresh. Thank you for having me. I really like having this conversation. It is really, really good.